All right, so we are looking at angle side angle first. So again, we're getting our last two ways of proving triangles congruent today. We've got 4 so far. We've got 2 more coming today. This one is angle side angle, ASA. All right, ASA. And remember, you need to read that going around the figure. We talked about that with SAS, where the A had to be the included angle. Well, now it needs to be the included side. Because the S is in between the 2 A's, it's got to be the included side. So it needs to be an angle, then a side, then an angle right away. Angle, side, angle. And you see it in the picture there. All right, we got angle, side, angle, angle, side, angle. Okay, 2 pairs of congruent angles, 1 pair of congruent sides, and that side is the included side. That makes it ASA. Okay, so that would be enough to lock these triangles into place and make sure that we have congruent triangles. Okay, okay, good. So that's just like SAS, just like SSS, right? We're going to use this to prove triangles congruent. It's just another way that we have here to prove those triangles congruent. So we have ASA, and we'll take a look at some proofs in a little bit. But I want to talk about the other one. I want to get both of them out of the way here. So we had ASA, and now we're going to have AAS. So very similar, right? Very similar, but there is one difference, as I'm sure you can see. It's the order of the letters. All right, the other one was ASA, now it's AAS. So now we don't have an included side, we have a non-included side. And we have a non-included side. So we have a side that's not in between the 2 angles. You can see it here, right? Angle, then an angle, then the side. Angle, angle, side. So AAS, angle, angle, side. Okay, good. But very important here as well, not only is it a non-included side, but with the other triangle, it has to be the corresponding non-included side of the other triangle. So it still has to match up. It's not enough just to know that you have 2 sides that are congruent that are not included. Because let's say that we didn't know this, we said that this was congruent instead. Now, this isn't going to work. This does not work with AAS. Yes, I've got 2 pairs of congruent angles. I've got a pair of congruent sides, but these sides don't correspond, right? This side is matching up with the 2 arc marks. This side is matching up with the 1. So if this were the case, and again, we're ignoring that. We're saying that this was the congruent side. This would not work for AAS. That would not work. So that's the one that you got to be careful of. We got to make sure that they are corresponding. That if this is with the 2 arcs, this is with the 2 arcs. And those sides match up. Okay, so we got to be careful on that. So we've got angle, side, angle, and we've got angle, angle, side. Very similar. The difference is where that side is, or where that side is. So if we look at this, we can kind of prove this theorem by using ASA. Right? So what this does, this saves us an extra step or 2 in a proof. So if we have this situation, what we could do, let's pretend for a second that AAS is not a thing. AAS doesn't exist. Okay, we'll pretend that. If I had these 2 triangles and I wanted to prove that they were congruent, I still could do so by using third angles theorem. Third angles theorem, I could say that B is congruent to E. Right, by third angles theorem. Now, once I have that, now I could use angle, side, angle. I could use ASA, angle, side, angle with that third angles theorem. What this theorem does, it knows that I could do that every single time I have this set up. I could do that. This is a shortcut that allows us not to have to do those extra couple steps. So it says, all right, I've got this situation. I know I could do third angles theorem and then ASA, but I don't have to. Because we know that is available, that can happen in this situation every time, we can jump straight from this situation and say, these are congruent. This is AAS. These are congruent. Okay? So that's what we're looking at. Those are the two that we're looking at today. ASA, AAS. That goes along with the other ones that we've learned, right? SAS, SSS, HL, and definition of congruent triangles. Okay, so we've got 6 total here that we have to use, we have to choose from. We got to be ready to use in any situation. All right, so let's look at this picture. Okay, we're looking at this diagram, and we're trying to figure out, do we have enough information to prove that these two triangles are congruent? So I want you to look at it, I want you to think about it. Do we have enough information, and which theorem would we be using? So the key here is remembering what those arrows mean, what those arrows represent. Remember, those arrows represent parallel lines. So if we have parallel lines, the very first thing that should be going through our head is AIA. Every time we have parallel lines, we're looking for AIA, which means parallel lines cut by transversal, also interior. So I'm looking at the 1 arrows here, the left and the right, cut by the transversal. Right? I got that Z shape. Got that Z shape. So that means these two are going to be congruent. So I know 2 and 4 have to be congruent based on those 2 parallel lines. If we get rid of those 2 parallel lines, we think of the other 2 parallel lines. Now I'm looking at this Z shape. Right? That's enough to say that 1 and 3 have to be congruent. So AIA gets us to those 2 different pairs of congruent angles. And then reflexive property, YW and WY, reflexive property tells me that side is congruent. That's the included side, so this is angle, side, angle. Angle, side, angle for that. Okay, so yes, we have enough information, and it would be ASA. All right, we got a couple proofs to look at. You guys, when we're looking at this, obviously I have no way of knowing if you're learning these proofs, if you can do these proofs, if you cannot do these proofs. So you have to be honest with yourself, right? You know that you're going to see this stuff on a test. Test is going to be Monday. So you're going to see this stuff. You're going to see this stuff on a midterm. You're going to see it next chapter, right? It's not going away. So you need to be responsible for your own learning, and you need to put the time in and say, all right, I got to figure this out. I got to make sure. If I don't understand, I got to ask a question. Type it in the chat, reach out, talk, right? Unmute yourself. But we got to be able to do these proofs. Okay? So here's what I'm going to do. I'm going to give you a couple minutes just to think it through. Okay? Think it through. Think about what could we say. Can you find how to use ASA? Because it says right there, we're using ASA, right? I'm giving you that hint. So we want to figure out how can I use ASA here. So I'll give you a minute or two, jot some stuff down or think about it, and then I'll come back and I'll discuss it since you guys don't talk. So let's take a look at it. Hopefully you've got something. Who can tell me, either through the chat or speaking up, who can tell me one thing that we can do here?
Alternate interior angles. You could get angle D is congruent to angle C.
Okay, so alternate interior angles, D is congruent to C. So that would be something. Somebody other than Tyler. What else can we say?
There's vertical angles between ABD and CBE.
Like there?
Yeah.
Okay, good. So then we've got AIA, we've got vertical angles. Make sure we're naming those correctly, right? If we're gonna say A.
Oh, yeah, sorry. It'd be ABD and EBC.
Perfect, there you go. ABD, EBC, we just wanna make sure of that moving forward, good. So we got those verticals. So now that's enough. We've got angle side angle, right? That's it. So I told you moving forward that these proofs would become a little easier, right? A little more straightforward. We know what we're looking for. We can get a couple pieces of information and that's gonna be enough to prove the whole thing, right? You split up your givens. There's only 5 steps here. AIA was one, vertical was one, and then ASA at the end. Good. Very good. Okay, let's do another one. This one's going to use AAS here. So again, I'll give you a couple minutes, take a look at it, and then we'll come back together, we'll talk about it. All right, here we go. So we've got the left and the right are parallel. We've got the fact that these two are right angles. Right now, we have nothing congruent. Okay, in our proof, we have no sides congruent, we have no angles congruent. So we need 3 things. Okay, who can tell us one of those things that we can say?
Reflective POC. You can say that HG is congruent to GH.
Okay, there you go, GH and HG by reflexive property of congruence. Good.
Now you can use HL to prove the triangle is congruent.
We would need another pair of legs congruent, and we don't have legs congruent. We have legs parallel, but we don't have legs congruent, so we can't use HL yet.
You could use AIA to prove that FGH is congruent to KHG.
Okay, so let's take a look at that. All right, because this is pretty common here. But if I'm talking about these 2 angles, that's this Z shape, and it's using these 2 lines, and we don't know the top and the bottom are parallel.
Shoot.
Right, so we can't say those angles. That's very common. I'm glad you said that. We got to be careful of it. right? So it's not those two angles.
You can say that HGK is congruent to GHF,
There you go.
and then you could do AAS angle side.
Well, I only have one pair of sides and one pair of angles so far,
You have two right angles.
right? But we haven't said anything about that yet.
Oh, so you'd have to say definition of right angles to say they're congruent.
Not definition of right angles. Anybody remember what that is?
Right angles congruent.
There you go, right angle congruence theorem. So we have to state that those angles are congruent. The reason we can say that the F and K are congruent is because of right angle congruence theorem. So right angle congruence is going to tell us that those two are congruent. Then that's enough to say angle, side. Okay, so we actually have to state that. We have to state that those two right angles are congruent. So if we look at the finished proof, all right, we've got that given. We used AIA, make sure it's the right angles, the correct angles, I should say, the correct angles for AIA. Because they're right angles, we can use right angle congruence theorem. We've got reflexive property. That's enough now to use AAS for that. Good, good, good. Any questions about those couple proofs that we just looked at? Okay, I want to show a couple things here. You know, we've got all these letters, all these ASA, AAS, SAS, SSS, right? All of these. The ones that we haven't listed, the combinations that we haven't listed don't work. Okay, so you can't just make up some combination of angles and sides. The big one that people mess up or that they want to use would be what we saw in the warm-up, which was two sides and a non-included angle. Let me get this off the screen here. So it would be, the one that people mess up would be if we had something like this. Okay, this combination does not work. Right, this is not SAS, it's not AAS, ASA, SSS, right? It does not work. It's not HL. If you were to use those abbreviations, right? SSA, not a thing. If you read it the other way, it should be, you know what that would be. You can't be swearing in the paper, so that's not a thing, right? We cannot use angle side side. That is not a thing. Okay, so do not use angle side side. It does not work. Let me show you why that doesn't work. Okay, I got a little thing. It's linked in Schoology, but I'll pull it up here. There is a reason besides the fact that, you know, that was a naughty word, why angle side side doesn't work. Whoever's got their mic on with the TV in the background, let's maybe cut that. All right, so we're gonna take a look at why this doesn't work. So here's our two triangles. Right, this is why it doesn't work, because you could have two triangles that have that same angle and have those same two congruent sides, but those are obviously not congruent triangles. Right? That combination, the side-side angle combination, does not lock this triangle into place. It's not enough to prove that the triangles have to be the same. That's why we have to know another angle, or we have to know the included angle, not one of the non-included angles. So that doesn't work. And they show the visual here, right? How that side QR is the same length. We don't know any information about AC and PR being congruent, so that side can change as much as it wants. So side-side angle does not work here. Okay? So we just gotta be careful of that. All right, so we've had 6 different ways of proving triangles congruent. Here are 5 of them remember that sixth way is the definition of congruent triangles. We don't use that one very often. We're not going to use definition of congruent triangles if we can use all these other ones, right? So that's just more work. That's 6 pieces of information you need rather than 3. So these are the 5 that we're really going to use that we have to know, right? This is a nice kind of chart here on page 273 if you ever want to look at it. But it's got all of them listed out there that you can study from. Well, we got SAS, SSS, HL, which is right angles only or right triangles only. We got ASA and AAS. Those are the ones that we can use. On the test on Monday, you're going to have to be able to do all of these. Right? You got to be able to recognize them. They're not going to tell you. Like in the lesson that we just did, it said use ASA. It's not going to tell you on the proof on the test. You're just going to have to know. You're going to have to figure out, all right, what information do I have and what can I do with it? Which one of these can I go off of on there? Okay, so you got to know them, you got to learn them so that we're good to go. Okay. Any questions right now on those last couple that we talked about? No? Don't hear anything, don't see anything. I'm assuming that means that we're good. Okay. So tomorrow we move on to 5-7. And that is, what do we do after we prove triangles congruent? So we're going to extend those proofs by another step or 2 tomorrow. But for today, we're proving triangles congruent. Okay, and that's where we're going to end those proofs still.